Okay, this is a review on how to simplify radicals. So the first thing that we need to do is we need to break down 90. So we're going to break it down into a tree. So we got 9 times 10. That's 90. Now, 9 can be broken down to 3 times 3. All right, there's your leaves. And 10 can be broken down to 2 and 5. There's your leaves. Once you've broken it all the way down to the lowest form, you put it underneath the square root. Okay, in order, if you remember, I said this is like the dating game. Everybody's in the house at a party. And so you see these two people end up dating, which means they get to leave the house. So if they leave the house, they come out as one, and then what's left inside are those people that did not find somebody to leave the house with. Therefore, it is 3 square root of 10. Let's go to the next one, because the next one is a pretty large number. So I have to try to think about, what goes into 1,764? Because 4 is even, we know that 2 does. And 2 goes into it 882 times. All right, here's one of my leaves, because 2 can't be broken down anymore. Now, I know 2 will also go into 882. So 2, there's one of my leaves, can't be broken down. And what's left is 441. Then we can use the divide by 3 rule, where if you add up those 3 numbers, 4 plus 4 plus 1 is 9. Since that's divisible by 3, we know this is divisible by 3. So 3 is as low as it goes. So this is 147. Again, I'm going to use that 3 rule. So 1 plus 4 is 5, plus 7 is 12, which is divisible by 3. So we know this is divisible by 3. There's another leaf. All right, that's divisible by 3. And what's left is 49. 3 times 49 is 147. Now I know 49 is 7 times 7. There's all my leaves. All right, everybody's going in the house. So I've got 2 times 2 times 3 times 3 times 7 times 7. If you look, I've got 3 couples. Therefore, they can all come out of the house. 2 times 3 times 7. And there's nobody left in the house. That's equal to 42. Done. Let's go to the next one. Okay, now we're talking about bad manners. Remember that you do not wear your hat at the table when you're eating dinner. And that's what we have on the bottom here. So we need to get rid of the square root of 3's hat. To get rid of its hat, we multiply by itself to both the top and the bottom because we're not prejudiced. So when I do that, remember roots go with roots. So what I have now is 50 times 3, and then square root of 3 times the square root of 3 is the square root of 9, right? And the square root of 9 is just 3. That was the reason that we multiplied, to get rid of the hat. Okay, we still have to simplify. So I know that I can break up 50. 50 is 2 times 25 times 3. Now, wait a minute. I can break up 25. So now I've got 2 times 5 times 5 times 3. So pretty much what I'm doing is I'm just doing the tree inside the square root, all over 3. All right, wait, there's a couple. So therefore, they get to come out of the house. So 5, 2 times 3 is 6 over 3. My answer is 5 square root of 6 over 3. All right, here we go again. Bad manners. So we want to get rid of the hat. Can't wear your hat at the dinner table. So multiply by itself. So now I've got 120 times 6. All over, we're getting rid of the hat. All right, I know I can break 120 down. And if I think about it, that is 20 times 6 times 6 over 6. So actually, I've got a couple right here. Let me go ahead and pull them out the house. 6 square root of 20 over 6. All right, I know I can break down a square root of 20. So 6 equals, and that's 4 times 5. which is also 2 times 2 times 5 all over 6. Oh, look, it's another couple. They get to come out. So now I've got 6 times 2 square root of 5 all over 6. And we all know from elementary when you have a fraction, you can get rid of the top and the bottom if they have the same number. So our final answer is 2 square root of 5. Okay, now let's do a little bit of review on the special right triangles. So we're doing our tic-tac-toe. So if you remember with our tic-tac-toe, we always put, let me make this a little bit bigger so I'm working on this one alone. All right, we always put our angles in the correct order. So I have 30, 60, 90. And then we went over before, because this is all a review, we went over what the formulas were. The formula is x square root of 3, and 2x. Again, going in the correct order from smallest to biggest. Okay, these are our equations. So what we need to do is we need to find out, we need to put 24 somewhere. So 24 is opposite the 90-degree angle, which means 24 goes where the 90-degree angle is. All right, that's my equation. Take that equation up here and solve it. 2x equals 24. Divide by 2. So x equals 12. So now I know what x is. So I can go back here and I can put x is equal to 12. And then here, I'm just replacing this x right here with what x is. So 12 square root of 3. So now if I go back up here, I know x is opposite the 60-degree angle, which is right there. So this is 12 square root of 3. And y is opposite the 30-degree angle, which is right there. So y is equal to 12. All right, let's do the next one, which is our 45, 45, 90. Once again, we're putting our information in order, 45, 45, and 90. And then if you remember, we had our formulas, which was x, and x square root of 2. All right, here's our equation. If we look, 34 is opposite the 90-degree angle, so we put 34 here. All right, this is our equation. Let's put it up here. X square root of 2 equals 34. Divide by the square root of 2. We're trying to get x by itself. So now I've got x equals 34 over the square root of 2. Whoa, that's bad manners. Hats on the table. So we're going to multiply by the square root of 2 to the top and the bottom. And I end up with 34 over 2 square root of 2. Now remember, wholes goes with wholes, roots go with roots. I've got a whole number 2 on the bottom and a whole number 34 on the top. So I can go ahead and reduce my fraction and get 17. So x equals 17 square root of 2. Go back over here. That means x equals 17 square root of 2. So opposite the 45-degree angle is my y, which is opposite the 45. So it's equal to 17 square root of 2. And same with this one, because this is a 45, 45, 90. Therefore, it's an isosceles triangle, so the two sides are congruent. And that's it.